Hey guys, how's it going? So I just wanted to expand. Last time we had talked about statements, and it's hard to talk about those at depth without expressions. So we're going to learn about that. We are also going to learn more about how to make this rainbow. We're going to learn ellipses in order to do that, which are funny circles, which are stretchy circles. What I want you to think of them as. So to get started, let's see here. A statement we did last time was hello world. And this statement, and I will probably, let me comment this out for now. Oh, it does not like that. Let's save our sketch. And then that is not the right button to comment things. We'll come back to that. So this is a statement, and we can do things that we didn't talk about last time. Not sure if we covered it. We can print out a number here. It's fine with that. We can also print out, we can evaluate a mathematical expression here. And that would be something like this. And I know it might seem, the question with math always is, what am I going to use this for? We could use that um, right here soon. This will help us make a rainbow more sensibly. So we can evaluate that. We can go even further. We can do something like this, where we are having a series of expressions that evaluates in our print statement, and we could put this in a circle. So we could have some complicated formula of different math functions and get something for, say, the height of a rectangle or the length of a line. We could do that within there, and it's fine with that. Whereas when we were trying to do multiple things, it is evaluating these expressions into our one statement. Whereas before, if we tried to do something like this, we had real issue, and we have to include this. But this is still one statement here. It just has a series of expressions, and you know if it's an expression because generally it will come out to a quantity. That quantity can be something a little more abstract than solid numbers that we have, but it will come up to something that the computer can have a value to. The things that we render to screen aren't quite values in the same way to the computer that something like 10 plus 10 is. And you don't have to use parens everywhere if you know your order of operations well, PEMDAS, if you remember. You don't have to. It is almost universally considered great or better style to not rely on somebody to know that, not rely on you get it right, but to put anytime you want to do a math, to have it just parentheses out exactly how you want it. So like if I was doing this, um, I would probably even go further and have it something like that. Oh no, I'm getting backwards. So I would, if I was wanting it to be this way, I would I would print this way. I would make sure that you know 5 and 3 get done, 10 gets done with them, and then we add 10 to it if that's what I wanted in some world. So in order to do this rainbow, we really had blocky things last lesson. We had triangles and we covered rectangles and squares. Well, what we're going to have here, I have a little bit of code pre-written you might have saw. We're going to have, where is, oh, I guess I deleted it. All right, fair enough. We're going to have ellipses that are going to be like how rectangles were. So our square only needed 3 values because it knew the height and width were the same. We're going to want to use ellipses here, I think, because we can stretch our rainbow out, we can squish it down. A circle you can move, but it's just a circle. It is the same thing as if you think of an equilateral triangle or a square. It is a set, like it's within reference to each other. We could maybe grow the total circle. You can grow a total equilateral triangle. You can grow a total square. You can shrink it, but so just when you're deciding what shape to use in order to do an animation or something using processing in Python here, use um, just be aware of what you can and can't do with those. So if we actually would want a background first. I really like that blue that is used frequently in the book. We do have to enclose it in quotes here, and we have to include the hashtag for it to know that this is a color code. And we should go ahead and fill up our, let me find a good color. I would like an orange to contrast with maybe a yellow. Let's do something a little different and have a yellow. And then we need to have a size to our window. We're just going to do a square. It's big enough for now. We're going to close all these windows that spawn from running statements. And let's just start it at somewhere where we can tell this ellipse is going to have an x value, a y value, and then a width and a height, which is exactly how that rectangle functioned. So we have this, and now just to show you, we can do circles. They definitely have their uses. I would, if you were ever doing something that was exactly a circle, if you had a tire to a car, you would know that it's going to be the right height and width if you just go ahead and stick with this. Let's close this, open that. You can see it's perfect, and you can add to this number or not. So we should be able to have this be the same if we evaluate an expression here. It evaluates the same thing. So we can load this function that draws an ellipse for us, this statement that puts an ellipse out onto the screen for us. We can put equations in here. And right now we're using magic numbers because we haven't covered variables, but at some point you will have variables that will be something like so let's say that you had something like this. We can put this in place. We can put that in place. Makes our circle bigger. And you might at some point say, well, it's a little too big. And you can do that. And there will be times where you might have, I think it'd be more helpful for animation when we get to that point. And I'll show you a case now with these ellipses. So we can go ahead and try. What we're going to do is attempt to make a rainbow here. First thing is a rainbow, Roy G. Bibb, red, orange, yellow, green G. Bibb, green, blue, purple. So we're going to start over here. We'll have red. We will go ahead and just do our first ellipse, which our size and width and all that are way off. Let's think, if we want to start it probably halfway through, and if we think about the 0 point, since 100 and 150 puts it only at the top left, that 0 point is on the top left. Let's get it halfway down our screen, which is an 800 size. So we can do 400 and do the same here. And because like we covered last time, this ellipse will draw off the screen. We don't care. We have our window into the world. We'll catch, we'll cut the circle in half, and we'll have that. And it's just a simpler way. We don't have to deal with arcs and other things that we will get into. But for right now, we can just go ahead and start here. This will be way off, but it gives us a rough idea. Oh, I'm silly. It probably needs to be at about 0, actually. Yeah, so this is better. Red won't be quite the right color, but we have the right starting point. We have the shape. This could be a rainbow. You could imagine if you layered up, we'll have a rainbow. So we can just go ahead and get through that. The height and width both would probably need to be changed drastically. Let's just see if we make this very large, what we're dealing with. That's probably about right, actually. So we're at 800. We might actually want to go even bigger with the size of the window, or we could just stick with this for now. So we have red, orange, yellow, green, blue, purple. So we have 6 values we want to cascade down. Well, we know that we're going to have to do this a number of times where we fill in a new color. And that orange, we were actually playing with an orange just a second ago, and it was something about like this. Should get us close, I believe. We will have to move this ellipse down in order to see it. So we've got to think that in a rainbow you have this arc. Well, it'd be easier to think of like this. We're kind of drawing this sideways, and then you have one come under it, and then under that, and then under that. Well, so that means that it is a smaller total ellipse on both ways. So if we want to do 700, we can subtract 100 from each of these and then have it not show up because I did something. Oh, so this happens sequentially. This is actually good to know. So this happens sequentially where we fill red, we draw a circle. We fill orange, we draw a circle that's smaller. We're doing it again here because I was trying to just get ahead of ourselves and copy paste things. We'll go ahead and wait on that. So we fill this red circle, we fill an orange circle. Now we're not overriding what we already did. So you can think that orange circle was there or was there until we overwrote it with something else. But we can go ahead. And now this will be a really cool way you can get a better feel of the hex color system where we're starting with F's, which capitals might make this read a little better. Just look nicer. So we're starting with F's, which is 15. That is the highest value you could have in your red slot. Then we say, okay, go ahead and give me about halfway with this. And we'll go ahead and crank this up real quick. Let me close all these. And I'm doing it again. Go ahead. And you'll see that's actually yellow now. So if we get halfway, would be 7 or 8. 15's odd, and you can't do 8.5 or anything. It takes whole numbers. But we do now know that, well, if we just take 200 off of this, we can get there. And you could make this a variable if you wanted and say rainbow height, and you could even make it shorter. I would recommend you capitalize the start of something like that so the word's more apparent. There are also other kinds of ways to do that. Whatever looks good to you is what you should go with. So we can kind of see that we go from, we have this fill, we have what's in F maxed out, then we add some here to halfway, then we max this out. Now we're simply going to take this away, make this even smaller here, and you can kind of see how it's happening both ways on how we are moving our colors over and we're shrinking this down, and we don't have to write the actual value. And while nothing, when you're working on a small example like this, everything seems silly. Anything that isn't the smallest amount possible. So just bear with on that. That it is. I understand if you're thinking, well, why don't we just write 500? Go ahead. But just show you that it works either way. So now we'll kind of do the opposite of this, and we will add in this ellipse up here. Why am I typing? Don't type when you can copy and paste. There's really no point. So 800 is that, minus that. Did we skip one? Red, orange, yellow, green, blue, purple, and then purple would filter back to red. All right. So that means if that's blue, then to get purple, that's not quite right. We skipped. Doing this backwards, we would need FF, and that would be AF. Okay. We'll go ahead and try that real quick. Red, green, blue. So this is a blue-green more than anything. Interesting. Let's go ahead and draw this way. That would be definitely be a solid blue. So the thing I'm missing is we need to purple, we're gonna have to do red and blue. So I'm kind of just getting into the weeds on that one when I shouldn't be. And going blue. But we can go ahead and see. We'll make a fun rainbow here. That blue is very close to that, and then we can, in order to get purple, we will loop over around to doing that, which makes sense because if we're going to go through all the colors step like halfway by halfway, you know, halfway up on this value, then halfway down on that, or I guess we're not doing a half step down on the prior side, but we will still get around to that. And so that is like a weird, that is like the ugliest possible purple here. I wonder if doing like an 8-8 makes a prettier color. We're gonna try that real quick. That makes a much prettier purple, so we're gonna go with that. I don't even think that purple is pretty, but man, that one was bad. So this isn't, we could cut out one of these blues. I think it would look more like a stereotypical rainbow if we were to do that. But hopefully something that this covers that you might not would see anywhere else. Normally you're just copy pasting hex color values just to, oh, I found the color I want it. You can kind of see it, and while that's not, maybe it's not super helpful, but there will be some times where you are reading through something and you see something and you can sort of visualize that. Hey, sorry for the cut there. We're going to wrap it up here. Video's getting a little long. We'll cover arcs and Bezier curves on the next time so we can do some fun little shapes, make some hearts, all that fun stuff. Thanks for tuning in.